Have you ever thought that a computer could solve problems impossible for every machine on Earth combined? In this video we explore the massive quantum computing breakthroughs of 2026 and what they mean for the future. Stay until the end because this technology could change security, medicine, finance, and science forever. If you love deep tech and future predictions, make sure you subscribe, like, and comment your thoughts. Let us step into the world where physics meets computation. 10. The moment quantum stopped being theory. For decades, quantum computing felt like a promise that never fully arrived. Scientists talked about its potential, but real-world impact remained limited and uncertain. In 2026, the conversation changed dramatically as major breakthroughs pushed quantum machines into practical territory. Researchers achieved stability levels that were once considered impossible to maintain. Error correction improved faster than expected, and systems began running longer calculations successfully. This shift marked the moment quantum computing moved from laboratory curiosity to real technological contender. The world began paying attention as results started outperforming classical methods in specific tasks. This year may be remembered as the turning point. 9. What makes quantum computers different? Classical computers process information using bits that exist as either 0 or 1. Quantum computers use qubits, which can exist in multiple states simultaneously through superposition. This allows quantum machines to explore countless possibilities at the same time. Entanglement allows qubits to remain connected even when separated, creating powerful computational relationships. These properties enable quantum computers to solve complex problems much faster than classical systems. Instead of checking one solution at a time, they evaluate many possibilities in parallel. This difference changes the entire concept of computation itself. 8. The breakthrough in error correction. One of the biggest obstacles in quantum computing has always been fragility. Qubits are extremely sensitive to noise, temperature, and environmental disturbances. Even tiny vibrations or electromagnetic interference can cause errors in calculations. In 2026, researchers introduced new error correction methods that dramatically improved reliability. These methods allow quantum systems to detect and fix mistakes during calculations. Longer computation times became possible for the first time in many experiments. This breakthrough unlocked the door to real-world applications that require sustained processing. Reliability is the foundation of practical quantum computing. 7. Quantum advantage becomes real. The phrase quantum advantage describes the moment when quantum computers outperform classical machines in useful tasks. In 2026, several research groups demonstrated this advantage in real-world scenarios. Complex optimization problems were solved faster than classical supercomputers could manage. Simulations that once took weeks were completed in hours or minutes. These results proved that quantum computing is not just theoretical hype. It is beginning to deliver measurable performance gains. This milestone represents a major victory for decades of research and development. 6. How medicine is being transformed. Drug discovery is one of the fields experiencing massive benefits from quantum breakthroughs. Simulating molecular interactions is incredibly complex for classical computers. Quantum machines can model these interactions more accurately and quickly. This allows researchers to design new medicines and treatments faster than ever before. Diseases that once required years of research may soon see faster solutions. Pharmaceutical companies are investing heavily in quantum research partnerships. The future of medicine may depend on quantum simulations. 5. The cybersecurity earthquake. Quantum computing poses both opportunity and danger for global cybersecurity systems. Many encryption methods rely on mathematical problems that classical computers struggle to solve. Quantum machines could potentially break these encryption systems much faster. This threat is pushing governments and organizations to develop quantum-resistant security methods. The race to secure digital infrastructure has already begun worldwide. New encryption standards are being designed to survive the quantum era. The future of privacy is entering a critical transition period. 4. Finance and global markets. Financial institutions are exploring quantum computing to solve complex market prediction and optimization challenges. Portfolio optimization, risk analysis, and fraud detection require massive computational power. Quantum systems can analyze huge datasets and identify patterns faster than classical methods. This could lead to smarter investment strategies and more stable financial systems. Banks and hedge funds are investing heavily in quantum research teams. The financial world is preparing for a new era of computation-driven decision-making. 3. The hardware race between tech giants. Major technology companies are competing fiercely to build the most powerful quantum hardware. Each company is exploring different approaches to qubit design and system architecture. This competition is accelerating innovation at an incredible pace. Governments are also funding national quantum initiatives to remain competitive globally. The race for quantum leadership is becoming a new technological arms race. Breakthroughs are happening more frequently as investments continue to grow. The competition is pushing the field forward faster than ever. 2. Challenges still standing in the way. Despite incredible progress, quantum computing still faces major challenges. Scaling systems to millions of qubits remains a complex engineering problem. Maintaining stability at large scale requires advanced cooling and control systems. Software and algorithms must continue evolving to match hardware progress. Researchers are working on hybrid systems that combine classical and quantum computing. These challenges remind us that the journey is far from over. The next decade will determine how quickly quantum computing becomes mainstream. 1. Are we finally beating classical computers? The answer is both yes and not yet at the same time. Quantum computers are outperforming classical systems in specific tasks but not in everyday computing. Classical computers still dominate general-purpose applications and consumer technology. However, the gap is shrinking rapidly as breakthroughs continue to appear. The future will likely involve hybrid systems where both technologies work together. The era of quantum computing has officially begun. The world is entering a new chapter of technological evolution. The next decade will reveal just how powerful quantum computing can become. If you enjoyed this deep dive, make sure you subscribe, like, and comment your opinion. Tell us whether you believe quantum computers will dominate the future. Share this video with someone who loves science and technology. We will see you in the next exploration of the future.